on to example 2. So we're going to look at an example that is not a polynomial. So here's a function that has an exponential with a polynomial using product rule. And so I sometimes like to make a chart and then summarize up here. So I'm going to very first go through and find the critical numbers of the function, and then I'm going to use a sign chart to determine where the function is increasing and decreasing. Those two things kind of go together. So very first, I'm going to take the derivative. This involves product rule. So we have first d second. So first is e to the x. The derivative of x squared minus 3 is times 2x. Plus second d first. So plus x squared minus 3 times the derivative of e to the x is e to the x. In order to find out when the function is increasing, we would need to know when the derivative is positive. And in order to do that, we would need to find the critical values. And the critical values are where the derivative equals 0 or is undefined. In this case, there are no spots where the derivative is undefined, so I'm going to just go ahead and find out where it equals 0. So I'm going to simplify my derivative from above. So we have 2x times e to the x. I'll just reorder that. If I would distribute this, this would be plus x squared e to the x minus 3e to the x. And you might think, well, how in the world algebraically without my calculator am I supposed to figure out where that's 0? So what we're going to do next is these all have a factor of e to the x. I am going to go ahead and pull that factor out to the front. What you're going to notice then is you're left with a quadratic, and so I'm going to write that quadratic in standard form. So x squared plus 2x minus 3. And that quadratic can be factored. So this factors into x plus 3, x minus 1. So my sign chart then, or my critical values are, when does this equal 0? So e to the x never equals 0 because it's always positive. So that's going to help us in a little bit when we do our sign chart. No matter what we put in for x, e to the x is always positive. X plus 3 equals 0 when x equals negative 3. And x minus 1 equals 0 when x equals 1. So I'm going to have two critical values then. So those are the potential extrema. And so those would occur at negative 3 and at 1. So this is my sign chart, remember, of the derivative. Let's keep in mind from prior, when the derivative is a positive number, that means that the function is going up or increasing. And so that's what I mean. This kind of ties in to several pieces. So if I picked something to the left of negative 3, remember I'm putting it in for these three things. So if I put a negative 4 in, for instance, e to the negative 4 is going to be positive. If I put negative 4 in there, that would be negative and negative. So this is a positive value. I like to use 0. This is always positive. E to 0 is positive. 0 plus 3 is positive. 0 minus 1 is negative. And then if I picked 2, for instance, positive, positive, positive. Okay, so I'm going to summarize with my chart up here, and then I'm going to answer the question for relative extrema. The first interval I have is negative infinity to negative 3. On that interval, the derivative was positive or greater than 0. What that means is that f of x is increasing there. The next interval is negative 3 to 1. F prime of x now is less than 0, or a negative value. That means the function f is decreasing. And the last interval is 1 to infinity. F prime of x is positive again, so that means the function is increasing. The justification for increasing is just stating this. The AP grader wants to see that you understand that a positive derivative value means that the original function has a positive slope, so it's increasing. Let's answer the question then. So if the function here is increasing and it switches to decreasing, what has happened at negative 3? There is a max, because f prime of x switches from positive to negative. So that's my justification. This is what's called the first derivative test. Okay, so you're using the first derivative to decide where extrema occur by where it switches signs. At x equals 1, we have a function that switches from decreasing, so going down, to going up. So what has occurred here is a minimum. We want to use calculus, the derivative. So the reason why is because f prime of x switches from negative to positive. If I asked you to actually find the relative extrema, you could plug in like f of negative 3, and you could just leave it, okay, into the original, sorry. F of negative 3 would be e to the negative 3, let's see, what's negative 3 squared is 9, minus 3 is 6. So if I wanted to actually find what that max was, that's 6 over e to the 3rd. I don't know what that is, but I know it's its maximum, and if I wanted to find its min, I could plug in 1. So we'd have e to the 1st, 1 squared minus 3 is negative 2. So negative 2e is the minimum. Alright, the last thing I would like to look at today is, what if you're given a graph of the derivative? And so the key thing here is that this is a graph of f prime of x. Some key things to understand though is, let's highlight when the derivative is positive. So the derivative is positive here and here. and the derivative is negative all the way there. So that might be helpful in figuring out what's going on when you're trying to relate graphs. So the derivative is positive from -3, it looks like, to -4, and from 4 to 5. F prime of x is less than 0 from -4 to 1, and from 1 to 4. And I'm writing this separately because technically it's 0 at 1. Okay, so when we're trying to find when x has a relative maximum, let's ignore the graph right now. What we're trying to look for is when f prime switches from positive to negative. Okay, because when that happens, the function switches from going up to going down, so a maximum would occur there. So on the graph, we're trying to identify where f prime of x, that's what we're looking at, switches from positive to negative. So the first value at which that happens is x equals -2. And actually then that would be the only one. For what values of x does f have a relative minimum? So now, by the way, this is our y. I like to identify that first. We're looking for f prime switches from negative to positive. So where that happens is it's negative, it's 0, careful, it's 0 here, but this is one of those critical values that doesn't give us an extrema because the sign doesn't switch, stays negative, finally switches from negative to positive at x equals 4. So that is where the relative minimum would occur.